Hey everybody, and welcome back. Today we're going to be continuing with our investigation using a Monte Carlo-esque simulation to be running multiple predictions at one time, whereas we know the random forest, so we'll already, it runs several iterations of the forest creation and usage. What we'll be doing essentially is taking that randomization and running it through a little bit more randomization. So we'll be getting a wider range of predictions for our players, and then we're going to be doing a little bit of analysis on that. So we can take like the average of the predictions, or if it's a good matchup, maybe the 75th percentile. If it's a bad matchup, maybe like the 30th percentile of those predicted scores. If you're unfamiliar with what a Monte Carlo simulation is or how to use it, go ahead and check out the previous video where we go over more of the basics of it. But today we're actually going to be applying it to a real life FanDuel player list, like we would be doing during the normal season. It's not going to be a direct, one-to-one comparison, because obviously this isn't the regular season, but the general process is going to be the same. So let's go ahead and hop on in. We're going to be doing the exact same startup as we did before. We're importing our modules, we're bringing in our sample data, double checking to make sure everything comes in how we want it. And now this is where it's going to be a little bit different. We're actually going to be bringing in a player list from January 4th, 2020 that I just happen to have. And it's going to be our direct FanDuel. You go to make your lineups, you download your player list with the predictions and the salary and everything. This is the sheet you get. I did bring in 2 extra columns at the end for some reason, but no matter. So we have everything we're going to need. We have the player, we have their salary, we have the fantasy points per game, team, opponent, etc., etc. So what we need to do to connect what we've done last time and what we're going to be doing today is last time, if you remember, we went through and we basically just trained and tested our data set over just the box scores information, right? And we pretty much were just looking at the last 3 game rolling average, 5 game rolling average, 7 game rolling average, and their season average. But we were using data that we had trained on when we were making our predictions and analyzing, right? Because we were just predicting a fantasy point score for every single game that season we had box score data for. What we're going to be doing now is we're going to be pretending like this is a real, an everyday situation. We're going to be taking our box scores. We're going to be getting our 3, 5, and 7 data, and we're only going to be applying it for the players playing today with data from games before that date. So what we need to do is we need to take our sample data for YouTube file. We need to slice off all of the game data from January 4th and later. And then we're going to take that last 3, 5, 7. We need to get the most recent entry for each player on our player list today, because in reality we would be looking at the last 3, 5, and 7 games as of January 4th, 2020. The one thing we're not going to worry too much about is going to be the season average, because that's going to be the average over the entire box score data set. But we're not actually predicting to put in the lineups right now, so I think that's okay to let slide as it stands. So first thing we're going to do, we're going to sort our data set, which again is our sample data for YouTube file. We're going to sort that by game date. We're going to drop out from our player list all of the players with an injury indicator of out, because we know they're not playing for sure that day. There's probably going to be some that are a game time decision or questionable that end up not playing, but for purposes here, we're just going to drop out everyone that we know isn't playing. We are going to So we're going to drop out everyone with an injury indicator of out, right? So if we look up here, these guys happen to be NANs, and a NAN just stands for not a number for pandas. That just means there's no data there. Think of it like a null or a none. So we're dropping out everyone that we know isn't playing, and we're setting the index to nickname or the player name. And then after that, we are going to be creating, just kind of slicing down that data set. So instead of having all of this information that we don't need, because really all we need off of here is the player name, and then we're going to keep their team they're playing for, just so we can because I like to see that. There's no real reason why. With the player name being the index, we need to call at least one column to bring with it. That's going to be team name. The team name isn't going to serve any part of analysis. It's just, otherwise we're just pulling a series and not a data frame, which would be okay, but this is a little bit easier. We're going to make a copy of our initial data set, give us data set 2. In data set 2, we're going to set the index to be the game date, and then we're going to take a look at it, and now we can see that the game date is now our index instead of the player name. That's perfectly fine. We're going to create a data set 3, That's going to be data set 2, where the index is less than or equal to 2020 1/3 or January 3rd, 2020, because we need everything of January 3rd and earlier. Take a look at that. Now we went from February 13th to January 3rd, and now we need the most recent entry for every player. So we're already sorted by game date. So if we sort by player, we can see that we have a whole bunch of duplicates for Aaron Gordon, right? So we can't just join this up with our player list because we're going to get all of these records for every player. We don't want that. So what we're going to do, and one convenient thing with keeping the season average where it is, given this scenario, again, normally we would just have a data set that exists that's pulling in the most recent information for each player. But since we have data past that point, we're going to have to do a little bit of manipulation. So we're going to group by player and season average, because you'll notice the season average is going to be the same for every single record for each player. So there's no difference there. So each of these are going to look like one record if we only look at those two. And an important thing to note here, we did not create a new data set. Okay, so this is data set 3, but since we didn't put sort values in place equals true or define a new data set, that's just temporarily in memory. So if we go back and do a data set 3 head, we're going to see it back ordered by game date. All right, so don't worry about that, because the next step we're going to be grouping by player and season average and keeping only the first record. So I know this looks like that would be keeping the oldest record, but again, if we actually look at data set 3, it's going to be the newest records first. So we are going to group by player and season average. We're going to keep the first record. We are going to sort by player name, and as we can see here, we no longer have duplicates for every player, sorted by player name. So if there was another Aaron Gordon, he would be right here. If there was another Avery Bradley, he'd be right here. So now that we have the most recent record for every player, and we can see up to the most current point of January 3rd, we have their actual last 3, 5, and 7. And we're grouping by season average, so it's not going to show up over here, but we can fix that pretty easily. What we're going to do is we're going to reset the index for data set 3 and then set the index again to player, all in one statement. Take a look at that. Now season average is bounced out and is a normal series, and we have the player as the index. So now we can go ahead and start working out how we're going to join this data to our player list, because we only want to be predicting players that are playing that day. That's exactly what we're going to do. We have player list 2, and we're going to define that as player list joined with data set 3, and it's going to be a left join. Now, for those of you not terribly familiar with joins, they're fairly simple. You have a left-hand side data set and a right-hand side data set. However you're joining, if it's a left join, for example, we're keeping everything in the player list, and then we're only adding information in from data set 3, where in this case the indexes match, because both their indexes are the player names. If we were matching on something that wasn't the index, we would have to specify that column, but since it's the index, this is all we have to say. If we had done a how equals right join, then we'd be keeping everything in data set 3 and only matching the player list to that where the index is matched. Okay, but we don't want the whole data set, we only want the information for the players on our player list, so it's going to be a left join. An alternative would be an inner join, and that's where it's only going to keep the records where both indexes match. So that means if we have information in the player list that doesn't have an index matched to data set 3, that record is not going to be brought through to our final joint data set. But we are going to do a left join because that brings up a good point that we will be addressing at a later point. We're going to go ahead and we're going to join our data sets, and then we're going to take a look at it, and as we can see, now we have the 2 columns from our player list. Remember, we just kept the nickname and the team. And then we have all the information that's coming from dataset 3. So season average, matchup, fantasy points, V3, 5, 7, right? So now that we have all the information that we need in one spot, we're going to go ahead and we're going to trim that down so we're only keeping the last 3, 5, 7 in the season average, right? Because we don't need all the rest of it to feed into our algorithm. And then if we take a look, and we want to sort by last 7, we can see there's a whole bunch of nans here. And what these are going to be, these are players on our player list that whether we don't have data for them in our data set, or whether the spelling of the name does not match directly. So for instance, Frank Mason, we do not have him as it's spelled and presented in our data set. So this is a good opportunity to bring up how we ideally will have some sort of linking mechanism, primary keys, foreign keys, whether it's just a dictionary you have for each data source, etc. You would slide through here prior to this and replace the player names in one of the data sets, probably your data set with your actual stats. Replace those names with how it's going to be spelled for FanDuel or DraftKings or wherever you're playing, so you don't have to deal with manually connecting these each time. We'll be getting into that in a later video explaining how we do it, but I just want to point out that that will happen if the names don't match up. And it could be, for instance, if a player has been injured and they haven't played, then we wouldn't have data for them, we'd have the same thing. Or if it's a rookie who is, beginning of the season, we don't have any previous stats for them, it'd be the same thing. So either you don't have it, or it just doesn't match the name, but you do have something for the player. One of those two things. So all we're going to do for the purpose of this example is we're going to drop NA, which that is going to run through our data set, and any record, any player that has a NAN in any column, we're going to drop. Just get it out of here. So you want to be a little bit careful when you're using this, because if you're only looking at dropping if there's a column, a specific column that's empty, like if we only wanted to drop players that we, for whatever reason, didn't have their last 7 average, then we want to be specifying that specifically. But right now we're just going to drop everything, and then we're going to look at last 7 again. Now we don't have any that are blank, which is good. We're going to actually start getting into our predictive model. And this should be more familiar. The point of going through all of this was to have a data set to feed in once it's been trained. So instead of running it over our normal features data set, we're going to be training and testing the same with our full data set, and then we're just going, or with the data set up until January 3rd at least. And then we're going to be feeding this in. So all of this data will be something it's never seen before, because this is for January 4th, and we have all the data for January 3rd. So this will be the first time we've really fed data that is going to be a full data set that it's never seen before. So just like normal, data set 4, we're going to have data set here. And then feature names is going to be the exact same as it normally is. Labels same, labels features same. Now, what we're going to do here, there's 2 primary ways to go about doing this type of analysis, and there may very well be another algorithm that does it automatically for you. That's great. But to understand what we're doing and why and how, we're going to be doing it ourselves, and just like we've done previously where we loop through and define the randomness and run it each time, this is going to be very similar to that. This is when we are retraining our models for every single contest, right? Because within this for loop, we are making our predictions and we are training and testing our model. So if we ran this over and over again, we're going to get very different results, which if that's what we want, that's great. If we have a large enough data set, this can become a little bit time consuming, all right? These 3 steps here, really just fitting it to the data. But anyways, so it can be a little bit unwieldy if we have a big enough data set. Just for NBA games, we're probably not going to get to that point unless you just have a massive amount of data you're feeding in for every single one. But for what we're doing now, it's not going to make a difference. This will give you the most up-to-date model every single time. Now in general, going from day to day, like once you get a decent chunk of the way into the season, a single game's worth of stats is not going to significantly alter their overall stats, right? At the beginning of the season, yeah, every single game, because game 1 is 100% of their sample size. Game 2 is 50% of their sample size. Those are going to have pretty big opportunities to change the stats and therefore change how your model reads it. However, once you get into the season enough, you're at game 30, 35, that game is 1/35 of the data you have for them. So each subsequent game is going to have a less of an impact on your overall model building. For the big stats, obviously your last 3, 5, 7 averages, those are going to be good, but that data is still, the data is going to change, but the model itself isn't. It's not like if they had a good game yesterday, suddenly their last 3 game average is significantly more or less important, right? We might actually want to look at it less, because now it's looking at an outlier for last 3 games and it's going to pull it up. But that's all stuff that it's a little beyond what we're doing here, but just to give you an idea, typically you would want to retrain your models every now and again, whether it's every couple of weeks, once a month, whenever there's enough new data sitting out there you haven't trained on, that you want to bring in so it can kind of recalibrate itself, right? So this is going to be the exact same as we did before. The only difference is for our predictions, we are feeding in player list 2, okay? Player list 2 for our predictions. And if we take a look at that, this is what player list 2 looks like, which is just like the data we've been feeding in before, but it's specific to that day. So that is what we're feeding in for predictions. And then our train and test is going to be over all of our data from January 3rd and previously. So let's see how we do. And for anybody that hasn't seen the previous video yet, what we're doing here is we're defining an empty data or a data frame of player list 2, making a copy of it, and then we're running through our predictions. And then for each iteration of the model, we are appending our predicted fantasy score to our compare data frame that we made up here. And then we're just doing a predict underscore n so we can see the random variable that was fed to it. So now that's done, let's take a look. And now we can see we have last 3, 5, 7 season average and then the varying predictions here. And the degree of variation here is going to vary based on the player and how their stats feed into it. As we've checked several times in the past, we know that this algorithm is going to overwhelmingly favor the last 3 average. So if we look at a player that, alright, so let's see, Bradley Beal's last 3 games is significantly lower than his last 5, 7, or season average, right? And if we look across these numbers here, they're going to be much closer to his last 3 game average than 5, 7, or his season average. So that's a way, I mean, with only 3, 4 stats here we're feeding it, it's pretty easy to see those things. When you're using a bigger data set, it's not going to be quite as clear cut, but that's one way you can kind of take a look at it and see what you're doing. Whereas alternatively, Brandon Ingram here, it looks like they are down on Brandon Ingram for some reason based on his last 3, 5, and 7. Don't know why, but that's how it goes sometimes. So now that we have done that and we have our output here, and if we were to run this again, let's see, Giannis was, what do we say, 51.85 to 45. So 51.85 to 45. Let's run it again and we'll see what we get. Alright, so we ran it a second time. Remember, for Giannis, we went from 45.6 to 51.85. If we look at it again, now we were at significantly higher overall. Our lowest one's a little lower at 47.9, but our highest one's all the way up at 58.353. So as you can see, we're getting different results because we're having different random variables here that we're using. So that is just kind of driving home the benefit, potential benefit at least, of doing this sort of thing with different variables. Because if we had done how we'd done before, where we'd train it, test it, run it, and that's it, we would be getting exactly one of these columns were the predictions. So as you can see, there can be pretty wild variations. So anywhere from 58.4 down to 47, that's a pretty big jump, right? And if we had only gotten this one at 47, we probably wouldn't be very high on Giannis tonight. If we get only the one at 58, we might be a little too high on Giannis tonight. So it's good to have more of a variety there. And all of this is predicting off the exact same variables, okay? Only these data sets. So if there's that much variability between prediction run based on just this right here, imagine how much more variability you're going to get once you start bringing in much better data points to run your model off of. So I hope that kind of drives home the importance of this, or not necessarily the importance, but the value that it can bring your own personal setup. Because if you're running this, I mean, you're going to hit a point where it's, you know, how much time it takes to run versus the value you're getting out of it. You're not going to run a million predictions every single day, because that would be a little unwieldy, or maybe you do, I don't know. Maybe you have much more powerful computing hardware than I do, and you can do that pretty quick. But for me, I would say at most 100, right? 100 of them. That way you're getting nice even breakdowns for your 50th percentile, 75th, and 25th. That's just me. You can do whatever you want, obviously, whatever works best for you. But now, if we want to compare to what they actually were, we're going to take our dataset sort values, go by game date, and we're going to create a new data set. We're going to set index to game date, and we're going to look at only 2021-4, and then we are going to only keep the fantasy points in the player name, and we're going to set the index to player. So now if we look at it, these are the actual fantasy points scored by every player on January 4th 2020, which again is the day that we made predictions for. So let's go ahead and we're going to join our data sets here. And we are going to do a right join because we want to keep everything in our compare data frame because we're really only looking for players that we have predictions for. And then we're going to join this data set to it. And then we're going to drop the last 3, 5, 7 season average. So we're only going to be left with our predictions and the points they scored. And as we can see, we have, and the reason we did a right join here is because I wanted to illuminate this fact. For example, we have Bradley Beal here, who does not have a fantasy point for the day, but we have projections for. Remember, we only drop players that were already designated as out. If we had done a left join here, let's go ahead and do that. Oh, we can't. We have to redefine dataset new first. Okay. So if we look at dataset new and we do a left join, so we're going to be joining our predictions to our new dataset, then Bradley Beal should not be here. Dropped again, and well, would you look at that? I guess we got to sort by player name. Sort values, player, dot head. Bingo. Now, if you'll notice, now we have players with a fantasy point, but no projections. Those are going to be players that we dropped because the names didn't match or we didn't have stats for them. But you'll notice Bradley Beal is not on here because he was not in the data set because he didn't play that day. So that is the difference that should help you understand right and left joins, I guess. Maybe a little more hands-on. Player. Oh, that's right. Whoop. Alright, so now we have our projections, the actual fantasy points. It looks like we would have been better served for Giannis on the first set of predictions because he was a little bit low. Luka, we were way under. Andre Drummond looks like we, well, not too bad. That's a pretty big swing there, 36 to 50. Whoa. So yeah, so let's just give you an example. And again, this is a terrible data set to try to make predictions with. Only doing last 3, 5, 7 season average is not enough to give us the information we want. But to give you an idea of the types of variations you can get and why it's important to have multiple predictions, I think this kind of drives that home a little bit. Now, in the next example we're going to do, not in this video, in the next one, we're going to look at how we can combine this process with, if you think way back to a while ago, we did a video on pickling our models to save them to use for later. We're going to be combining these two things, and we're going to be going over how to run our randomization here to train X number of new models, save them locally, and then be able to pull them in on a daily basis and use them. So we would only need to do this part one time every time we want to update our models, and then we would take in these two and these two, and those are the ones we'd run every day. So we don't have to train test and fit them at all. We're just going to be pulling the model in with the preset everything, and then we're going to be running our predictions. So that's going to be it for today. I would like to give, as usual, our big thank you to everybody in the Patreon. It really helps out having the support there and being able to chat with everyone in the Discord, see what kind of projects you're working on, not necessarily DFS related, but it's good to see that the folks that are here in the audience are not only taking this and taking it to their own individual kind of courses they've been working on their own to do their own, learning, and what they're interested in isn't necessarily what we're doing on the channel right now. And be able to help them out with that kind of stuff, it means a lot, as well as seeing what they're doing completely unrelated just to try and get better at Python. And I really appreciate seeing that too. And I'm honored to be a part of that. So, thank you to everyone there. If you're interested in joining, check out the link in the description. Get in for the lowest $5 a month. And if you want to see this entire Jupyter data notebook here with the descriptions and everything and some links to the actual files that we're using, be sure to check out nixniche.net, where those will all be downloadable and viewable for your pleasure. Thank you all, and I'll see you next time.